Yeah, so we finished on the inheritance, and you said that inheritance is bad because of it's based on data mostly.
Yes, and yes, behavioral inheritance would have much flatter trees, and it's not worth the trouble.
Okay. What do you think about object relational mapping, if you know what it is?
Oh yes.
So what do you think about that?
Okay, so in the very first days that objects were being used, and when you were doing things with Smalltalk in particular, you would take 6 weeks and write a Smalltalk program.
Mm-hmm.
And then you would take 6 months to figure out how to get the data into and out of a relational database. And there were all kinds of frameworks that were being made to try and make this easier to make this transition. In point of fact, relational thinking and object thinking are, diametrically opposed. I mean, they just, it's a bad thing, period.
Mm-hmm.
But then the database people started getting smart. There used to be, there still is one company called Gemstone still has an object database. And it's a really good object database. There was another one that was the best object database ever was a product called Itasca. And it never went anywhere. It was ended up being bought by a company in France, and now they use it in embedded systems. They sell bill of materials kinds of systems to large airplane manufacturers and people who have that kind of problem to solve. And interestingly enough, a relational data, if you're doing a bill of materials for a 747 or a big jet, mm-hmm. Printing a bill of materials from a relational database can take forever. Mm-hmm. With an object database, it's 30 seconds mm-hmm. to do this. So that's the kind of application that it's found, and people use it there. But the other database people, like the Oracle and so on, started doing all kinds of things to make their databases less relational and more everything else. Mm-hmm. So they added remote procedure calls, and they added these other kinds of things, and so they could come closer to simulating in the database technology mm-hmm. object-ish kinds of things. Mm-hmm. So my understanding today is that it's not that hard to do anymore.
To store in object format.
To map back and forth from relational to object is easier. I haven't done it for a while mm-hmm. since it was extremely hard. Mm-hmm. So I don't know if that's true that it's easier now than it used to be. Mm-hmm. But the whole relational model itself has been called into question. So you have non-SQL databases, you have MapReduce, you have all of these other kinds of database structures out there which are far more efficient and are far friendlier mm-hmm. to objects mm-hmm. Than a relational model is. So with any luck, relational technology will finally die.
You think so?
I hope so. It's you don't see it in the web, mm-hmm. and so as more and more things move to web and mobile and cloud and mm-hmm. things of this sort, the relational uses of relational technology mm-hmm. get smaller and smaller. They're going to be the old traditional back-end insurance companies or banks or whatever that mm-hmm. have these kinds of specialized needs. Mm-hmm.
So we will have object databases, you think?
No, I think you'll have some of these other kinds of alternatives. There is, I have seen a movement to create so-called intelligent databases, mm-hmm. which combine object database ideas with some of the text database mm-hmm. kinds of things mm-hmm. and learning capabilities and things of this sort, so that the database becomes more of a mm-hmm. intelligent knowledge store mm-hmm. instead of a stupid data store.
Mm-hmm.
And that might have
Mm-hmm.
some, relational isn't going to go away in my lifetime. I would like to see it die, but
It's not that.
it's not going to be that fast. But
The question which is difficult for me to answer, and I'm trying to like many times, how would you define what is an object? Because the Wikipedia says it's a set of attributes plus a set of procedures attached to them, and people say it's a small computer which you can give instructions and can give you the result.
Right.
Some people say it's a piece of memory,
right.
where some data is stored and there's some type of this data. So what would you call the object? What is it? In your book, it's defined as a quantum, which the universe is built from.
Yes. So I would say the closest to the standard kinds of definitions, an object is an intelligent virtual computer.
Uh-huh. And
the intelligent part means that it behaves just like a human being would.
Mm-hmm.
And if you anthropomorphize
Mm-hmm.
an object, when you're thinking about it and designing it, if you think as if it was a human being,
Mm-hmm.
and say, well, I have to ask you what your name is, I have to ask you if you would do this service for me or whatever, and you are perfectly capable of doing these services. I mean, you have a resume,
Mm-hmm.
you say, I can do this and I can do that.
Mm-hmm.
So if you think of it as the intelligent part as being human intelligence,
Mm-hmm.
an object is just like another human being.
Mm-hmm.
The virtual computer part means that it has at its disposal anything it needs to do what it says it can do,
Mm-hmm.
Both in terms of knowledge and in terms of computing resources,
Mm-hmm.
for instance. So it, by definition, has its own thread in a multitasking machine or whatever. I mean, and it has access to all of the resources of the computer that it needs
Mm-hmm.
to do its work.
But still a computer, so it works for us. It's kind of, we are primary, he or she or it is secondary. Or no?
No. So, for instance, if you're designing a user interface,
Yeah.
People usually think of a user interface as the human being
Mm-hmm.
interrogating the computer or asking things of the computer. But if I was designing an application, so suppose I'm designing a form, which is an inanimate thing, it's a piece of paper, whatever, and I'm creating an object, which is a form. Well, that object then is going to see you as a data source.
Yeah.
It's going to ask you questions and say, well, I have this hole in my, in myself as a form. Are you a guy or are you a girl?
Yeah.
And so I can fill in the form.
Mm-hmm.
So no, it's, there is no master-slave relationship here.
Yeah.
You're peers.
Yeah.
With
Because when I'm
all of
looking
your
at the
objects.
object, which is a book, for example,
Yes.
I don't like to think about it as a computer. It's more like a thing for me, a
No.
book, which is. But some people say it's a computer, so you send an instruction, give me your title, and the book
Right.
says this is your title. It computes the title for me and returns back.
So is a Kindle a book or a computer?
The Kindle.
Yeah.
Well, the Kindle, yeah, Kindle is a smart book, probably.
Yeah, so I mean, the fact that it's a computer inside doesn't matter to you a bit.
Yeah, it
It's
doesn't matter what's inside.
it's a book just like the other book, and actually, it's a better book
Mhm.
because it can do things that a paper and ink book can't. I mean, things that are useful directly to you. Has nothing to do with what's inside of it or anything else. It's just all the way you interact with it.
Mhm.
So it has behaviors that are greater than the number of behaviors assigned to a paper book. So yeah, you don't have to think.
The definition, the
Yeah.
quantum definition, sounds better for me than a computer.
Okay. Yeah. Well, it's
Because computer smells like it's something
Yes.
secondary. There's somebody
Okay.
who asks, and
Right.
this guy computes.
yes.
But the book not necessarily computes anything for
Right.
me. It behaves for me. That's
Right.
my understanding.
So whether there's a computer inside an object or not is irrelevant.
Yeah. I like that.
It's behind the encapsulation. You're not supposed to know how an object does what it does. So therefore, by definition, you don't need to know if it's using circuits or if it's using corpuscles.
Yeah.
It's, doesn't make any difference to you. It's not important.
Yeah.
So yeah, you could drop the virtual computer part of it off and totally, and just say, it is an entity that can do things and might ask you to do things. And so the whole universe is built out of objects. There's actually a thread in philosophy. It has nothing to do with computing or anything else. Dealing with where objects came from is a philosophical and psychological concept. Why is it that we say that this arrangement of atoms is something and has stability or has other, characteristics or behaviors or whatever? There's a whole school of philosophy just concerned with that question, and that's very close to the quanta kind of notion. Is that for whatever reason, our human brains are configured to identify things, and these things are objects.
Mm-hmm. What do you think about immutability? You probably know what it is, immutability. So do objects have to be immutable, or they're okay to have these setters, which are, you
Yes.
make an object and then after the object is built,
Right.
you still inject something into it.
Yep.
Or the object has to be built once and that's it, and stay like that.
I've been having this discussion with a friend of mine, a former student who has become a very good friend. And my question to him was, show me anything in the world that doesn't change.
Mm-hmm.
Show me anything that doesn't change. So why should I be modeling things that fit this kind of an ideal? And he was trying to make the argument that in some areas of parallel processing and multi-core processing and things of this sort, that you can run into issues of identity. And again, these all sound so technical. He gets into deep programmer-ese to try to justify why immutability is a good thing or an essential thing in some cases.
Mm-hmm.
And I can't go there. I don't have that level of expertise in programming. But in all of our discussions, I still haven't found a reason that you would mandate things be immutable.
Mm-hmm.
It's
But the immutable objects are more like, let's imagine this is a book, and you create an object book, which is an object in programming, but it's a real book on the table. So
Mm-hmm.
they are like the same thing. So I'm talking to this
Mm-hmm.
virtual book, and there's a real book. And then while I'm still working with it, if it's mutable, I'm able to say, now you're representing another book. So that's what mutability, and that's
No.
what I think is not really good.
So I have a book sitting there on the table.
Yeah.
And it went through a long process of being written, being edited, being proofread, and it gets published.
Yeah.
And it's sitting there on the table. And I pick it up one day and I say, oh damn, there's a misspelling on page 7. It's immutable. I can't do anything about it. But my software book, I can change it.
Yeah.
I can correct it. And so
You change the content. You don't change the entire book.
yes, so immutability gets into questions of identity, and a confusion that we have. So you as a person, are you the same person
No, I'm changing
all the time?
all the time. Yeah.
Yes. Do you have a different name, a different social security number?
No, it's still the same. It stays the same. Yeah.
And do you have this sense that there is at least some little core, your soul,
Yeah, something
that has
stays.
been immutable all through all of these
Yeah.
changes?
Yeah.
And that's your real identity kind of thing. And so we have these confused philosophical concepts, or the way that we use language. And when we try to apply these language to computer programs and programming, we have a tendency sometimes to forget that it's just a metaphor for something that we're trying to accomplish over here. And it also ties into this notion of state. But that also gets back to a data conception of objects, that if you define your state of your object as the unique configuration of values in all your variables, you change one of those, you've changed your state,
Yeah.
then you can cause problems.
Exactly. Yeah.
But so then the question is that just another kind of an offshoot of a data view of an object, and a data definition of what state is, that is exactly the same as the definition of what class you belong to? If you have one more variable than something else, then by definition you're a different class of object.
Yeah.
I mean, somehow or other those two things are tied together. And if you think about the problem, you could think about, well, should this thing be stateful in this way? Or is there a way of isolating the variability part of it, of an object, from the invariability part of the object? So if you have an idea as an object, that value should be immutable. You get it when you're born and it stays with you forever. But things like your description, your height, weight, etc., or things that change, like people change gender. It's not immutable. Can you isolate that so that you have every object has a description, and that's immutable? But the nature of that description, or what kind of things are included in it, are not. And it doesn't matter. Again, it reflects reality. You can also deal with it with this sense of, the meta-object protocol, the fact of reflection. So if I have if somehow or other it matters to me that my value, I'm a stock in a portfolio, and my value, it matters, my value at 10 o'clock and 10:01 and 10:02 and 10:03. I have to know which one I'm dealing with, which is an argument for immutability. It should just be one thing, and if you have a new value, you're a new object. Why not just give myself a memory? And say, oh, well, you want to know my value now? Do you want to know my value as of, a particular date? And then you can have both. You can have simplicity of change. It's still one object, but it now remembers things about itself, which it can tell you using reflection. So.
When you think about reflection in general, that was one of my questions. In Java, it's like so popular, and you can do whatever you want with an object, with the class, with the variable.
Yeah.
You basically open it like that.
It's an extremely powerful tool, and it can be really badly abused. But I think it's essential. Yes, the whole idea of being an intelligent object means that you should be able to know things about yourself. And and again, if we think of people, we do this all the time. I sit here and say, I can lift that TV. Well, no, I'm kind of tired today. I mean, there's a lot of times that you use that kind of reflection. But when it becomes a technical term in a programming language, it then becomes a dangerous thing potentially. But as a design thing, it's essential.
So after the object is coming to me, for example, it's a book, and I'm receiving this book from somebody else, and then I'm looking at it. So I'm supposed to be able to like check what are the attributes there, or what methods do you have, or what is your type? From what class are you coming from?
Sure.
So I will can open it wide and see what's inside. You think we need that feature?
No, it's not.
Break the encapsulation idea?
No. That's not my understanding of reflection. My understanding of reflection is that the book will know things about itself. So it knows how many pages it has. It knows when it was written. It knows, and you can ask the object things about itself, and it has access to that information. That's things it needs to know. So if you send a message to identify a book, it uses reflection
on itself
to identify itself.
Yeah, but I'm talking in Java. It's possible to look at the book from the outside just look what's going on inside, and even change that on the fly, and say, hey, how about we just now add new method to you, and then remove this attribute from you.
No,
that's bad, right?
Yes. So I frequently use, and I don't remember if I put it in the book or not, but I used it in classes all the time. It says, I have the capability, the technology exists, that I could put wires in your head and press a button over here and make you raise your hand or do other kinds of silly things.
Yeah.
Would you like that? Do you want me to do that to you?
No.
Then why do you do it to your software objects?
Yeah.
It's a violation of the integrity of the whole philosophy of an object.
Yeah, it's like breaks philosophically, and encapsulation is broken, right?
Yes,
we just
absolutely.
don't encapsulate anymore. We just
Correct.
It's just the open box of things inside, right?
Yes.
All right, now the more philosophical questions for the future.
Okay.
We discussed that yesterday, but I want to emphasize it again. I see it very often, people saying that all these ideas about object programming, the right object approach is good, but in my practical work, when I go back to the office, people around me, they don't use that. And all the frameworks we use, they're designed differently. And if I start working like that, if I start designing objects like you're suggesting, like I'm suggesting them to do, they may fire me eventually, because I'll design software in a completely different way from everybody else. And my colleagues will complain, and my software will not fit into the entire product. So what do? They say, like, your ideas are nice, but they're not applicable to the real world.
Right.
So the problem is they're telling me, like, I will not be able to find a job if I follow these good principles of object-oriented programming, because the whole world, also that's another point, they're saying that the whole world turned away from these pure object-oriented ideas like 20 years ago, after Smalltalk kind of died, like you said. So we all decided, the entire Java world decided to go a different direction and use this data approach, and objects are just pieces of data with procedures on top of them. And now you're trying, I'm telling them it's time to go back, but they're saying no, the whole world is already moved away from that, and you won't be able to find a job if you do that.
Okay.
So what do you think?
So there's a whole mixture of things in there. Now, number one, sounds mean, but are you a coward? Do you have any individual, do you know that this is the right thing to do, and then you're chickening out on doing it because, or do you actually really disagree, that this is the right way of doing things? I mean, if you don't do something that you know is right, just because you're afraid of what your friends are going to say, it doesn't matter whether you're writing code or telling racist jokes. It's wrong. And you have to have the courage to do what's right. Practically speaking, yes, you will be putting yourself at risk of being fired. But it's not like jobs are hard to get out there for most people. If you have any skill at all, you're going to be able to get a job, and there are people that will appreciate what you're doing. And so it's not as big a risk as you think that it is. Slightly bigger risk is the fact that managers, particularly your IT managers, are managers because they were really good programmers 20 years ago.
In most cases, that's true.
Yeah. and so they say, well, hell, if I couldn't do it in COBOL, well, what good is it? And so you run into this dinosaur phenomenon that happens. And then the third sort of thing is that if you look at our profession isn't that old. It's only about 60 years old. But even in that 60 years, you keep seeing these cycles, so-called revolutions as they come through. So the first one was structured analysis, design, structured practices, which actually started off as programming structured code. But then it generalizes, and it's trying to solve the mismatch between the way that we're officially supposed to do things and the way that we know we should be doing things, and the way that would produce better results. So structured, and then actually databases for a while was one of these kinds of things that forced us to try and rethink our approach to doing things. And to that extent, data was really good, or databases were really good, because it forced us to look at the things that had some perseverance over time. Data lasts. Procedures don't. Mm-hmm. Procedures constantly are changing. So it changed a focus, and we made that change. And then objects, and then agile. At each one of these times, there's a little period at the beginning where you might have some influence. So in some ways, I wish that I had written my book in 1990, because maybe it would have, had some influence on preventing some of the things that I don't really think it would, but it might have had this kind of thing. Well, right now we're going back into we're starting another one of these cycles. So Agile is now kind of burned out. Objects burned out a decade ago. A thing called Microservice Architecture is becoming the new thing to do. I mean, it's getting a lot of attention. People are talking about it at conferences and so on. If you read what it is, it's objects. And it's behavioral objects. And so maybe I don't use the terminology, and I don't talk about small talk or whatever, but I talk about how to make my Java code, my designs be this microservice behavioral object kind of design, and then go ahead and implement it in Java. You can do object programming in Java, it's just most people don't. So you pick your moment. So yes, if I go to my office today, people are going to laugh at me.
Yes.
But then Monday, my manager is going to walk in and says, "Hey, what do you know about MSA?" And you say, "Oh, hey, I know a hell of a lot about MSA."
Because I know objects.
Yeah, because, and you don't even have to say because I know objects. You can just say I know a hell of a lot about it, and then you just give them exactly what you want to tell them.
But is it possible, would you think, is it possible to get back to the original understanding of objects and do it right now? I mean, in current world, in this Java world, Java dominates with the data and procedures? I
think it would be very hard.
Very hard.
Once things get some momentum, the only way to deal with them seems to be to subvert them. Another attempt at revolution.
But it's a revolution, it's not evolution. We can't just go get back.
No, you could probably do that too.
Can we transfer slow programmers and our mindsets back to the proper understanding of objects from this procedural world which we have now, this command and control plus data?
Yes. So, yeah.
You think we can?
I think we can. It obviously would be a much slower process. because convincing people to change their minds is easier than shaping their minds in the first place, which is why the revolution kind of idea is more likely. But you can do that. Obviously, I believe you can do that, or I wouldn't have been teaching the last 20 years, teaching people to do this. And sometimes, you got a class of 30 people and 3 of them really get it. So you have to be prepared. Yeah. Yeah, I mean, you have to be prepared with this kind of low numbers or low volume kind of thing, but you do make a difference. And you see these people go on and be successful. So my friend, it used to really annoy me that my best students that really took the ideas that I gave them, and especially some of the object ideas and stuff, that they would go out there and make twice my salary in the real world, with my ideas. But they most of them have become really good friends, and they're successful, and they make changes, and you can see companies that they have worked with that are doing things better. And if you can be happy or satisfied with that kind of incremental change and stuff, yes, you can constantly make the world a better place. And you will eventually succeed. But the main thrust of the argument about what will and won't work moves from the technical, the programming, into the world of economics. Right now, we're still in a world where the people that are paying for software don't care. They'll spend $1 billion and throw it away tomorrow, and it doesn't matter to them. As long as their systems don't crash or whatever, I mean, they just really don't care. But I can't see that changing. So as long as it doesn't change, then you're fighting an uphill battle, because where's the motivation to do things right if you're a programmer? And that's really what a lot of the resistance that you were talking about is, that, I can't go and apply this at work tomorrow. And well, you certainly can. And yes, it carries some risk, but I'm not willing to, because, what's the motivation? What's the incentive? It's not going to get me a raise. It's not going to get me recognition. It's not going to make any difference in the company. The company's still going to throw the money away or cancel the project or whatever. And as long as that's true, it's going to be really, really hard. I do not believe that companies can continue to spend this kind of money forever. I mean, there's got to be some kind of accounting sooner or later. And the companies that are buying this stuff are saying, okay, I want what you're giving me for 10% of what you're currently charging me. Can you do it? Well, if you're a good object programmer, yes, you can. If you're a really good, skilled, traditional Java programmer, no, you can't. So, but don't ask me to tell you what day that is going to come.
Yeah, sure.
But I think it is coming. I think that it's just absurd, the amount of money that we spend and throw away on IT.
And that's because we're not doing objects properly.
In part.
In part, yeah.
Yeah, I mean, there's a whole bunch of things that we've learned over the last 50 years, particularly from the practice, that don't get used. Some of the ideas of structured design, the coupling and cohesion, and the kind of effort people went in to figure out what is it that makes one object coupled to another. What are the kinds of ways of doing it? They range from communicational coupling, which I have to know who you are if I'm going to talk to you or send you a message, which is the least form of coupling necessary, all the way up to pathological, where I have to know how your kidneys work in order to effectively use you. But people don't remember that stuff. Cohesion, and this is particularly in data objects, If you are building a data object, cohesion is defined by the methods or the functions use the data that is in your object. And that's the only reason that the functions are grouped together, is because they use the same data. Well, that's not good cohesion. That's really awful cohesion. The cohesion should be based upon your behavior. What are the things that you do? And what you need to know to do it, which is what you store in your data things, is irrelevant. You know, it's just, you just have to know that I have that knowledge. And you don't even have to have it in a data variable. You can ask for it as an argument. You can go off to a global somewhere like the system clock and ask what time it is if you need to know the time in order to do something. I mean, there's lots of ways you can get that knowledge. It just means you have to have access to it. Doesn't mean you have to store it.
Yeah.
And so if you go back to structured development and you look at all the conversations about what makes things cohesive, you could learn a lot about making good objects. And then from good objects, you can learn a lot about how to make good programs and everything else. So,
do you think we need new languages to write better code, or we can still stay in C++ and Java and write proper objects? Or we need to throw them away and forget them and to move forward?
Yeah. We probably need new languages, but I suspect that they're going to be more along the lines of the domain-specific languages, kinds of things, and that are designed as a way of expressing or articulating your understanding of the world. So expressiveness is going to be important. Things like efficiency, which C gives you, with zero expressive, maximum performance, those kinds of languages are not going to be valuable. General purpose languages goes back to the question you asked earlier about, hybrid languages. Why make general purpose anything? The world is moving away from that concept. Which would you rather have? An application like Photoshop, big, huge, massive integrated app, or would you like to have 10 or 11 apps that did specific things?
Yeah, that makes sense.
Which would you rather have?
The second option.
Yeah, and that's the way the world is going in general. And the same thing should be true of languages.
So you're thinking we're going to have specific languages, and they will be
domain-specific languages, for doing certain
proper
things.
or object-oriented.
You see that a little bit now. People who write games don't really write in Java. I mean, the game's engine may have been written in Java once upon a time, and then probably optimized into C or C++ for efficiency. But they're writing, the actual games get written in more of a pro English or natural language prose kind of thing, because it's what you're trying to articulate is the same as you're writing a novel. Java is not a good language for writing a novel.
Yeah, it makes sense.
And so gamers don't use Java to create a game.
So in this case, you're moving programmers away from computers. Kind of, right? That's
Yes.
what's happening. They were really close to computers when there was time of C and COBOL
Yes.
and Fortran. They really
Yes.
knew how computers work.
Right.
And now they will know how to
Right.
write an English poem. Right?
Yes.
So some programmers
Yes.
complain about that, saying, no, we are engineers, we're mathematicians, we want to know how computers work.
Right.
Bytes, bits, all this.
Yes, and this is very definitely a case of going back to the past. So in 1968, the software crisis that gave rise to all of these engineers and this whole profession and a whole academic discipline and everything else, it was because there were not enough programmers. The demand was huge and the number of programmers were very small. In part because the nature of a programmer. So if you were a programmer in 1968, you were a domain expert first and a programmer second. So when I got my first job in computing, it was at a bank. And I had to take continuing education courses in banking for the whole time I was there. Every year I had to take 4 credits, which meant 4 weeks of, training in banking. They never sent me to school to learn COBOL or anything of this sort. I was a domain expert who knew how to code. And COBOL was more than sufficient as a language to articulate what I knew about banking. Okay, I might have been a physicist, and Fortran was the language that I used to express my knowledge of physics. Okay, today programmers don't know anything about any domain except the computer. And this whole concept of new languages is that you as a programmer, you should be learning or mastering one or more domains, or how to think about, the problem space, and then find the language which will be specific to that domain. So Fortran works really well for physicists. COBOL works really well for banks. Why do I need Java in either of those cases? And so you're going to see more instances of languages reflecting the knowledge and the expressiveness that you need in a domain. Games are the best example of that right now that I know of in computing. But some of the things that people are doing in domain DSLs, it goes in the same direction. And Smalltalk was not an object-oriented computer language. It was a language that allowed kids to interact with and carry on a dialogue with their computer without knowing that it was a computer inside. It was just this, like a futuristic robot, somebody that we could talk to, and it could tell us interesting things and so on. But the whole language was designed to be a language of conversation, not a language of programming.
Not a language of moving bytes and bits.
Yep.
Right?
Right. Yeah. You weren't moving bytes and bits. You were writing a line with a pen. And what happened underneath, that was magic, that...
So it's okay for programmers to stay away from bytes and bits in the future, yeah?
Sure.
It doesn't degrade their,
Now there are...
their professional...
Right. There clearly are problem sets. So if you're Google and you have to come back in 1/10 of a second with 70 million search results, you'd better be damn technical in your code and your language, and you should probably be writing in C or assembler. So yes.
But there are not so many Googles in the world. That's
right.
the point,
Right. There's that many of them. For probably 95% of the programming that is done in the world, you don't need bits and bytes.
It's a good statement.
Yes.
Okay. All right. What would you recommend to read and to follow and to watch to people who want to think differently? Not this hundreds of Java books on the market, which are everywhere, but to actually change their minds.
Okay.
Who are these people who are talking the same? Like, your book is great, but who else? I asked this question yesterday to you. I'm repeating it again.
So there are a variety of different things that I would read. I would read some technical books, so some other people that have written about objects. I would read Rebecca Wurzbach's first book on designing OO. Not her second book, but her first book. I would actually go and read Grady Booch's first book on objects, it was the very first book published on object-oriented design. Okay. And the first few chapters in particular, he talks very much about behavioral kinds of objects and ways of doing things. He was a methodologist, and so he got very heavy into all of these different kinds of models and being able to articulate things, and so that part is less valuable. but when he was first talking about objects and so on, and was saying, it's a fundamentally different way of thinking. It leads to fundamentally different kinds of solutions and different kinds of problems. He's right on in that kind of thing. So go back to the very first 1990 version of object design and read that part of Grady Booch. I would read some of the papers that Kent Beck wrote on objects, and particularly on class responsibility collaborator cards. Again, they articulating, very clearly what was being intended. I would read Alan Kay's papers. Alan Kay never really wrote anything on objects, but I would read some of the things that he said and some of the presentations that he's made. He has one in particular that was late 90s, I guess. Why the Object Revolution Hasn't Happened Yet, where he talks again about this was what the idea, this is what the conception was, this is where it went wrong. So he's written a lot of papers, but not books of that sort. So those are the kind of technical things. I would go back and I would read a paper by Peter Nauer, which talks about programming is not a production process, but it's a process of collaborative theory building, because that is fundamental to the whole agile thing as well as the object thing. That what we're really worried about is how we understand the world, and then how the computer is going to help us deal with some aspect or some problem in that world, and how we build these theories. So I have those kinds of things on the technical side. Go and read David Parnas, a book that he wrote, or a paper that he wrote in the 80s. The software development is a rational design process, how and why to fake it, where he basically says that, this myth that we tell ourselves about how we develop software and the life cycle and things of this sort, how it's total crap. I mean, we knew this back then, and so you're reading these kinds of things, and that makes a difference. But then I would recommend that you read fiction. Or other kinds of, read some business books. Read some business books about agile and objects and business objects and complexity, because they know a whole lot more about themselves than you do when you're trying to build systems for them. I would read, there's a whole host of design books. In another month you can read my design thinking book, which again, it goes to how do you solve and think about problems that are complex and wicked, where you don't have requirements, you can't have requirements, you can't possibly know everything up front, but you have to figure out how to build it anyway and how to solve it anyway. Or what you do with really complex problems like building a city. Read Christopher Alexander's A City Is Not a Tree. Again, where he talks about complex systems and things of this sort. In fiction, I would recommend, there are certain kinds of things like Neil Stephenson has a book called Diamond Age. And he takes the concept that Alan Kay and, now I'm forgetting his name, they have the whole Dynabook concept that has been floating around in computing for a long time and led to the laptop and notebook computers kind of thing. It's all about, Diamond Age is about such a book and how people interact with it and so on. And it just brings new ideas to mind. Alan Kay said that if you don't read for pleasure, you can't read for purpose. So if you haven't been reading some fiction or something that's just plain flat out fun to read, then you're going to have a hard time digesting those Java manuals correctly. That programmers need more imagination. They need to understand the role of metaphor. When you do something as simple in a program as give a variable a name or give a function a name, that's metaphor. Kent Beck's Best Small Talk Practice Patterns is an excellent little book, and it talks a lot of things, about naming things and so on. So it's not really about small talk. It's about really excellent programmer practices and how you use metaphor and how you use kind of literate programming, writing for another human being as opposed for the machine, and have that reflected in your code. Makes it much, much, much better code. And it also helps you think about what you're doing better if you get the names right.
Oh yeah.
So I had a friend once. It wasn't a friend, he was a colleague. He was literally insane. He would check himself into a hospital for 6 months, and then he would check himself out of the hospital and get a job as a programmer.
Wow.
He had internalized the RPG language. It's a report generation language for old IBM mini computers. And the project that we were working on was to convert some RPG programs into COBOL programs because they were moving hardware. So you would look at his COBOL program, and his data division would have 40,000 switches. I mean, that's literally, switch 1, switch 2, switch 40,000, which then in his procedural code he would use to replicate the cycle of the RPG language for processing, whatever it was that he was trying to do. Do you think anybody else in the world could read that damn stuff? I mean, it worked. It worked, but it was you might as well throw it away because no one was ever going to do anything with it later. But programmers still have this tendency to either use silly names or, meaningless acronyms or whatever to do data and function and naming and things. Really a bad idea. So reading some of the things will make you not only a better object programmer, but a better programmer in general. Other kinds of fiction. There's a lot of it, a lot of science fiction out there. I would read a lot of things on science. I'd read some anthropology, particularly get a feel for how ethnography is done by an anthropologist. If you want to understand your users and you want to be able to see past what they tell you to what they really mean, anthropologists can teach you a lot about that.
That's interesting.
So Steve Jobs has said that he was successful at Apple because his whole life he lived at the intersection of technology and humanity. Business world talks about how it's no longer sufficient to be just an expert at X, Y, or Z, that you need to have this broader base of knowledge. Business also talks about, it started off as the T-shaped individual, that you've got this breadth of knowledge and then you have some depth in a particular area. Most programmers are just vertical lines. Sorry, but most programmers are just eyes. So you have to be a T, but then that was advanced to you need to be a pie-shaped individual. You should have your breadth in at least 2 areas of depth. And now it's a broken comb, that you've got this, varying depth. I mean, so if you look at a comb, it'll be thick in the center and then it gets narrower towards the ends. And then the teeth come down, and some of them are broken off. Some of them go down quite a ways. But you need to have, this variable breadth of knowledge is all of these T's. And the term that is tossed around again in the business world is that you have to be a modern polymath. So a polymath is somebody who knows everything that there is to know. And there hasn't been one since Leibniz is sometimes considered to be the last polymath, that everything that was known when Leibniz was alive, he knew or knew about and could, So the idea is that now you need to be this modern polymath. You need to know a heck of a lot more than Java and compiler tricks and things of this sort. The software craftsmanship movement, which sprang out of Agile, in its claims to be heading in that kind of direction. But again, their goals is that they want to know more about how to code. They also want to know more about the history of coding, so that if someone had a good solution 10 years ago, that they would know about it. But they still are, pretty much focused within knowing more and more and more about coding, and not anything about domains outside of coding, which is short-sighted. If you don't have this, but that's kind of a scary challenge for most people, to think that they have to do that. But that's the only way that you really, really get good at, especially at design, is to have this breadth of knowledge to work from.
Recommendations to our listeners. One last question: what are you working right now on? I mean, what the book or content? What's the next step after?
Okay, so I am just finishing a book with a co-author, Rebecca, in Sweden. Rebecca Rickner in Sweden, and it should be published in about a month or so.
The design thinking.
The design thinking. And it tries to take things that the design community, particularly our architects and graphic artists and things, these people that consider themselves to be real professional designers, they have been grappling with and finding ways to deal with unstructured, complex problems for a long time, and they're very good at it. The software world has not. So hopefully this is going to bring some ideas to the software community about how they can do a better job at solving complex, large-scale problems. The one that should come out in about 6 months is, I keep fluctuating between Ars Magna as a title and Living Systems Design as a title, so it'll probably be Living Systems Design. Okay. The Ars Magna, that's great art in Latin, and it goes back to a guy named Ramon Lull that you've never heard of, but he was the inventor of computational science. He lived in Spain, in Majorca, was a Catholic, was a mystic, and he built this computational device to help expose the mind and will of God. But he actually invented, so there were computers or calculators and stuff before him, obviously, but he was the first one to come up with a symbolic kind of computing approach. And then Leibniz took that and developed it into a more scientific kind of effort, and then it went into Descartes and gave us modern computing. But Ramon Lull is actually the original computer. And his book was called Ars Magna. So that's why I did this one. But Living System Design it's intended to be comprehensive. It's to go from point A to point B about all the things that you should or could be doing in software development in support of making an existing system better, enhancing an existing system instead of trying to build an artificial replicant. It's a whole lot easier to give somebody an artificial kidney or even an artificial heart than it is to build Data, the android. But that's, anyhow. And then the last one is that I'm actually writing just a very practical book. It's going to be relatively short on microservice architecture. Because again, I see that as an area where they are saying the right things about behavior and about how you modularize things that is almost identical to what were being said about objects in the 80s.
But here we still have a chance to do it right.
But here we have a chance to influence them, hopefully.
Okay.
So that's that book might actually come out fairly soon. But I'm working on that, and then I have totally restructured my web page. It won't be available until September. davewest.us, and it's going to have a couple hundred presentations and papers and things like that that I've written over the years. It'll have links to the books, and it'll have a blog, Feral Cogitation. So I'm decided I'm just going to put it all out there, and if everybody ignores it, fine. I'm old. But maybe it'll have some influence.
It will have, definitely. Yeah. I'll be the reader for sure. Okay, thank you very much.
Okay.
I think we're done.
Okay, cool.
Thanks.